Complex fractions. So let's simplify some expressions. In another video, I built a common denominator for these. Now we're going to do them a little bit differently. We are going to multiply through by the least common multiple of the denominators to clear fractions within fractions. So this is called a complex fraction because we have a fraction divided by a fraction. So here's the vinculum. And it would be nice if this didn't have a fraction in the numerator, a combination of fractions, and the same in the denominator. If we had one fraction only. Okay, so the way we're going to handle this is we are going to multiply by the least common multiple of the denominators. And our purpose for doing that is to clear the fractions. Now there's still going to be one big fraction, but we're going to clear the fractions within. So we're going to look at, notice here this is the numerator. We're going to look at the numerator for the numerator. So least common multiple, that's LCM. And we use it when we're trying to find common denominators. So what is the least common multiple of the denominators in the numerator? Well, we have x as a denominator. We also have y. They have no factors in common. So the LCM least common multiple will be x times y. Now we're also going to check the denominator, and we're going to find the least common multiple of those denominators in that denominator. X and y, well, they have nothing in common, so it's still xy. So if we consider the numerator and denominator, they both have the same least common multiple of their denominators. So we're going to multiply through by that over itself. We have an expression, 1 over x minus 1 over y, divided by 1 over x plus 1 over y, and we're going to multiply by the number 1. All that means is we are going to multiply by something over itself. Well, what is that something? We're going to multiply by the least common multiple we found over itself. We're going to do that to clear the fractions. So the least common multiple that we found was xy. So if we do xy over xy, yes, we're multiplying by the number 1. We haven't changed anything. Mathematically, our expression is still equal to the same thing. Okay, but it may be easier to visualize this if we write it a bit differently. We're still going to multiply by xy over xy, but let's write it as xy over 1 divided by xy over 1. Why did we do that? Well, this is a fraction and this is a fraction. Would be helpful if this was too, so we can see where things combine or they cancel. Same thing in the denominator. So we are going to do the distributive property. We're going to multiply this times each piece in here. Now that may bother you. I have a lot of students who aren't comfortable, don't like that distributive property on the right side. They prefer it on the left. So I'm going to show you if you want to change it first. So we are ultimately going to use the distributive property. But for now, let's use the commutative property. Most of my students prefer that first. For the commutative property, a times b is the same as b times a. So you could rewrite this as xy over 1 times 1 over x minus 1 over y. All I've done is switch the order. You see that? 1 over x minus 1 over y was on the left. Now it's on the right. Do the same thing with the denominator. The reason I'm doing this is some of my students, like I said, are a little more comfortable with the thing I'm distributing being on the left. So now we're going to do that distributive property. Remember that is a times b plus c is equal to a times b, multiply those, plus a times c. So I'm going to write this in several steps. I'm going to write this as xy over 1 times 1 over x. Do y'all see that? That's this times this. Now I'm going to do this times this. So we're going to do minus xy over 1 times 1 over y. And do the same thing with the pieces in the denominator. xy over 1 times 1 over x plus xy over 1 times 1 over y. We are distributing this times that first piece times that second piece. This times this first piece times this second piece. Okay. Distributive property. Looking here, we see some cancellation, right? There's an x in the numerator and an x in the denominator. Those will cancel. So we're left with a y for the first term. And notice I'm not putting a fraction because I have cleared that denominator. No more fractions here. It's over the number 1, right? So then xy over 1 times 1 over y. I can cancel this y in the denominator with that y in the numerator. So if you look, the only piece that remains is an x. Do the same thing with the denominator. xy over 1 times 1 over x. Cancel this x in the numerator with this x in the denominator. I end up with a y plus xy over 1 times 1 over y. I have a y in the numerator and a y in the denominator. They cancel. So I end up with x. This is your final answer. Okay, let's try another one. Simplify 7a over a plus 1 over a. Okay, we're going to do the same thing. We are going to look carefully at the denominator of our fraction. So it might be helpful to look at it as 7a and then a over 1 plus 1 over a. Looking at the terms in this denominator, let's find the least common multiple of the denominators from the denominator. Okay, so we have a over 1. Well, that 1 isn't very exciting. We have 1 over a. So the only one that really has an interesting denominator is the 1 over a. So our least common multiple is a. Now notice I didn't even mention it to look for the least common multiple of denominators from the numerator because there's no denominators here. The only denominator we have really is the number 1. So we're going to multiply through the same way we did in the previous example. We're going to multiply through by this. We are going to multiply the expression by that least common multiple over the least common multiple, which is a over a. So we're going to do this, least common multiple, least common multiple. Okay, so we have 7a, a over 1 plus 1 over a. We're multiplying all of that by a over a. And then we're going to multiply. We're going to multiply the numerators and the denominators. When you are multiplying fractions, if you have a over b times c over d, you multiply the numerators to get ac, you multiply the denominators to get b times d. Top times top, bottom times bottom. So when we do that, 7a squared. So in the denominator, we're going to distribute. I'm going to go ahead and leave it this way. We're going to take this and multiply it by that and by that. A over 1 times a plus 1 over a times a. We get 7a squared. Now, it may be easier to write these for they look like fractions. So maybe write this as a over 1 times a over 1 plus 1 over a times a over 1. So we can really see what's happening. When you do this, you see that nothing cancels here, right? There's not an a on top and on bottom. They're both on the top. So those don't work. But if I look at this next piece here of an a in the numerator and an a in the denominator, those will cancel. So we end up with 7a squared over a squared plus 1. Now notice, I did not write this over 1, and I didn't write this over 1. If you wanted to, you could have written it as a squared over 1 plus 1 over 1. We see that is exactly the same thing. Okay, let's do another one. We can look at this one the same way, even though there's nothing added or subtracted, it's all multiplied. We can look and notice that here's the numerator, here's the denominator of the whole fraction. We can look at the least common multiple of the denominators, 2x squared y, 2x squared y. Oh, they happen to be the same thing. So I'm going to multiply by that common LCM on top and bottom. Okay, so I'm going to multiply by 2x squared y over 2x squared y. So when we do that, we get x plus 3 times x minus 1 over 2x squared y times, it might be helpful to write this as 2x squared y over 1. All of that is over x plus 3 times x minus 3, 2x squared y. Again, maybe easier to write this as 2x squared y over 1, putting each of these over 1. When we do that, we see that some things cancel. 2's cancel, x squareds cancel, y's cancel. 2's cancel, x squareds cancel, y's cancel. We are left with x plus 3 times x minus 1 over x plus 3 times x minus 3. Then we notice we have a factor of x plus 3 in the numerator and in the denominator. We end up with this. Let's try another one. If we look here for the least common multiple, here's the numerator, here's the denominator. If I look at the numerator, I look at the denominator. There's only one. It's 3 times x plus y. And if I look at my denominator of the big fraction, it's 4 times x plus y. So if I want the least common multiple of both of those, they both have an x plus y in common, but I have to include the 3 and the 4 and the x plus y. Okay, so I'm going to multiply through here, like we did before, by the LCM over the LCM. So I end up with 2x over 3 times x plus y, and then 9y over 4 times x plus y. I'm going to multiply through by 3 times 4 times x plus y all over 1, divided by the same thing. And I'm going to cancel. 3's cancel. X plus y's cancel. Okay, notice I still have this, and I still have this. So I end up with 8x as my numerator. In the denominator, the 4 cancels with that 4. So I'm looking here. And then x plus y and this x plus y cancel. Okay, so you can see I'm left with this 9y. And I'm also left with this 3. So you get 9y times 3. So 8x over 27y. Just a different way to do it.